Okay, now this question is an electrolysis question. The way you know it, it's going to actually tell you it's electrolysis at some point, and that you've got lead chloride in this case, or some ionic salt that's been melted. So we've got PbCl2. Now that actually means we've got Pb2 plus and Cl minus. Make sure you start with ions. Now if you're a little confused as to knowing what the ionic charges are, you actually have some help. So if you look further down, somewhere in the question there'll be some voltages. So Cl minus, Pb2 plus. Cl2 and Pb doesn't actually exist at the moment. There is only ionic particles present here, making that up. Anyway, so first question is to do with observations. Now at the anode, Cl2 will form. Now you should know it's a green colour that'll be around the anode, and that may in fact end up being a gas. And if it was something like I2, that would be a brownish colour, and Br2 would be a yellow brown or yellow browny orange colour, something like that. But yellow brown would be a good response for that being there if it was bromine, for instance. But in this case it's green, it's chlorine. Now the anode equation is oxidation. There will always be oxidation at the anode, so it's going from Cl minus to Cl2, taking care to make sure you put a 2 there because there's 2 chlorines there. And in terms of oxidation number, just be very specific with this. So Cl minus is an oxidation of -1, Cl in Cl2 is an oxidation number of 0. You must link that to an increase or a decrease. In this case it's increasing from -1 to 0, so chloride is oxidized. Meanwhile at the cathode, the observation is a grey metal on the cathode will form. Okay, so that's true for many metals, that colour obviously. Now in terms of the reaction, simply Pb2 plus 2 electrons forms Pb. Now if there's just one electron, if that's what you're dealing with, remember you may have to multiply one of the half reactions by 2 to balance the electrons and cancel them. Now again, this is relating to oxidation number. Equally you could be asked about electron transfer. So it has an oxidation number +2, Pb2 plus, whereas Pb has an oxidation number of 0. That's a decrease in oxidation number, so it's reduced. So you must link decrease and reduced together. Okay, so decrease in oxidation number, that is. Now if we're talking about electrons, you'd be saying Pb2 plus gains 2 electrons and is reduced as it forms Pb. Okay. Remember to be specific with electrons when you're talking about them as well. If it's 1 electron, 2, etc. Now here's something that's more excellence. I'll just get rid of that there. The overall equation should be straightforward, just combining the E0 cell value, reduction minus oxidation, taking the reduction value coming from this because this is reduced, Pb2 plus is reduced, and so we expect it to be a negative voltage. Spontaneity. I'll make a statement that the E cell value has to be greater than 0 for it to be spontaneous, and that this isn't a spontaneous reaction as that E cell value, I should have probably put in there that it is -1.49 volts. Okay, taking a reminder that you must include units, is less than 0, so it's going to be not spontaneous. Therefore electrons won't flow freely, and an external power supply must be used. That's important to supply the electrical energy. The external power supply supplying that electrical energy is an important point to make with this non-spontaneous reaction. If you're talking about movement electrons, that's just how they move when they're oxidized and reduced, relating it to the anode or cathode and the external wire. Now, as chloride is oxidized, and be specific with the number of electrons, 2 chlorides release or lose 2 electrons to form Cl2. They move through the anode. Anode is always has oxidation, and they go through the external wire to the cathode, and at the cathode it gains 2 electrons to form solid Pb. Now I haven't put it in the question there, but equally you could be asked about ions. So just doing it, so that's positive on that side, negative on that side, and Cl minus there, and Pb2 plus. Now anions are attracted to the anode, so chloride is attracted to the positive, where that's the anode, and that's where it gets oxidized. So Pb2 plus goes to the cathode, where it gets reduced. Now if, that's a mess there, where it gets reduced, So red kit helps you because reduction at the cathode always happens, and cations go to the cathode in this case, but you'll know that they're attracted there. So when you're talking about it, for instance, the chloride ions are attracted. That's an important point to make because they are attracted to it, to the anode. Now I know that's positive, negative going to positive, where they're oxidized to form CO2. Now just to note, the sign, the positive and negative of the anode and cathode swaps. In electrolysis, the anode is positive, but in a galvanic cell it will be negative. Okay? Anyway, the Pb2 plus ions are attracted to the negative cathode, where it's reduced and gains electrons. So movement of ions, if you kind of have an idea of this little diagram here about what's going on, you should just be able to talk about it, just making sure you mention that they are attracted to the particular anode. There are some definitions you should know for all of this. You should know what an electrode is. It's an electrical conductor that's going to make contact with an electrolytic solution. So it's going to go into a solution so that those ions can make physical contact with it. If it's not a metal solid, it could be something inert like platinum or graphite. An electrolyte is a solution that contains ions and can so conduct electricity. Now the more ions the better in terms of conductivity. You should actually know what electrolysis is. It's the use of electricity to make a non-spontaneous chemical reaction happen, and that usually happens in an electrolytic substance, so it happens in electrolytes. So that's electrolysis.